This video is for Superstructure part in the Structure 2. We have 3 group members, and today's video is about 10 minutes length. In this video, it includes the main points we learned while doing the Stage 1 and Stage 2. First, we are in Group 2. There are some data shows on the website. The span is 6 meters. Height on high side is 3.7 meters. Overall shade length is 10 meters. Base spacing is 5 meters. Roof pitch is 3 degrees. Wind region is A. Wind terrain category is 1. And there is no shading, and the topographic effects is T4. My name is Yici Feng, and my parts are pulling design, girth design, design the central and end rafters in the shade, presentation and joints, and this 10 minutes video. In this project, we set the pulling space as 1 meters. At the beginning of the pulling and girth design, we can find the wind load is a very important part for them, because the different region, different terrain catalog, or topographic can lead to the different wind class. And the wind class is the most important things to determine the wind load. From the wind load, we can calculate the combinations of dead load or leaf load. Also, in the project, we can calculate the pulling and the girth, and we can choose them in the table. Finally, from the calculate, we need to check the serviceability of the chosen pulling and girth. Also, in the first, the pulling spacing, we choose it as 1 meter. This different pulling spacing can also lead to the different result. In the rafter design, we can find different span, and the overall shade length can lead to the different results. First, in the raft design, we should guess the raft self-weight in the design loads, and then we need to put the raft self-weight into the dead load and leaf load. And then the combination of actions will need this dead load and wind load. After calculate the combination of action, we need to choose the rafter in the capacity tables and to choose one universal beam. Finally, there is a serviceability limit state in the raft design. In this part, we need to check the chosen universal beam whether it's suitable for this raft design.
Hi everyone, I'm Yeung Chun Yip Tom. Today I will talk about what I had learned in the Structure 2. First, I want to talk about what I had learned in the site visit. In the site visit, I went to an industrial building and learned about the structure of the building. In the site visit, I saw different parts of the building, for example, cross spacing. Cross spacing sometimes look like a X and sometimes just a cross. And it can increase building capability. And the most important part is a cross spacing is very important when they had an earthquake because it affects structure standing. Besides the cross spacing, I also take a look of the need of the building, and I know different part of the structure of the need. Beside the need, I, ha- I had also learned about the apex of the building, which is the top part of the building. Beside the apex, I had also learned about the structure of the rafter, column, and the emerald manion. After the site visit, I learned different part of the structure of the building. And let's move on to the next part, the window. When we talk to wind, what immediately springs to my mind may be typhoon, which can bring damage to human and destroy housing. So, structure is important to protect our housing. And find the window of the building is the first step to build the correct structure. To calculate the window, first you need to check the limitation from the Australian code. Next, you need to know where are you live and find the wind speed region. Usually, the wind speed region is AB or CD. Third, you need to select the terrain category. The terrain category may be TC1, TC2, or TC2.5, just depending on the code. Then select the topographic class. As the effect of the wind based on the location of the house. The effect of the wind on a hill or on a ridge is different. Then select the shielding class. The shielding class can be full shielding, partial shielding, and no shielding. Just depending how many house or tree in that area. Then you can select the wind class using the above selection. Then you need to have a selection of desired wind speed and define the pressure zone. Then you can select the pressure coefficient for the wind class. Finally, you can calculate the wind pressure. After you calculate the wind pressure, you got the wind load. And then let's go to the next part. Design a column. Column design pretty similar to the girth design or rafter design. First, you need to find the area of the column and then find the dead load of the building and find the minimum dead load and the maximum dead load. Next, find the knife load of the building. Then, find the ring load of the building. Then, use the load compilation to calculate the load. In this step, usually you can find the compression of the column, and then you can need to get the length of the column, and you need to use the university column table and find the suitable one for your column. After that, you need to check the moment capacity and check the reversal action. If all the thing is okay, you have already designed a column. If not, you need to go back to a university column table and find a suitable one and check it again. And I think the above is the most important step of the column design. And I think the good design most likely will mention about by my partner. So I will not talk about it today. And I think this the end of my presentation. And thank you.
The purlin spacing is an important value that influences many things, such as dead load, lip load, and wind load. Different span and height of purlin and the wind terrain category also affects the result of design. The girth part is similar to purlin design. The dead load and live load of girth is same to purlin. However, the wing load of girth is different from purlin because the area of thrust, surface of wall and roof are different. In roof bracing design, the suction and pressure due to wind load on the windward and the leeward walls are important values. These values will be used when calculating the forces of intermediate frame and forces of end frame. The equal angles is also important because it will be used when designing all diagonal members. Only half the members need to be determined due to symmetry. The section selected is important in design too. There are many choices for the tensile and compressive load, but only one is the best choice. It is necessary to use the method of joint and software in roof bracing and wall bracing. Truss analysis in Structure 1 is useful in calculating member force. Every data cannot be tolerate error because it will influence the result of design. So every data that calculated should be accurately. Thank you for watching the video.